Apollo 1 was to be the first manned flight of the Apollo spacecraft, the capsule that would be the astronauts' living space during their trip to the moon. The program was ahead of schedule, and with the first launch of the Apollo capsule within sight, NASA was exceedingly optimistic about its progress, sending men to the surface of the moon. But during a manned test of the Apollo spacecraft, optimism quickly changed to horror, as the capsule was consumed in flames, killing 3 astronauts, Gus Grissom, Ed White, and Roger Chaffee. In the wake of this infamous disaster, NASA immediately launched an investigation with the purpose of identifying causes of the accident and to note what changes were necessary to prevent any more malfunctions. The purpose of this presentation is to provide a detailed summary and additional facts about the engineering malfunction itself, to present the findings of NASA's investigation in a simple, easy-to-understand format, and to explain the changes made to the Apollo spacecraft prior to the failure to ensure the safety of the astronauts on board.
The incident happened on January 27, 1967, at 23:31:10 GMT at the Cape Canaveral's Launch Complex 43, 220 feet above ground level. The Apollo 1 caught fire during a simulation launch. The fire was caused from a faulty electrical wire sparking, which then rose up through the cabin, causing the nylon surroundings to melt and spread the fire even further. With Clemens, a launch pad technician, and a few colleagues working just a few feet away from the Apollo 1 module, they attempted to remove the astronauts from the spacecraft, but they were unable to. The smoke being emitted from inside the cabin through the cracks was blinding and was suffocating everyone who tried to free them until further help could arrive.
Apollo 1 began as a routine pre-launch test. The 3 astronauts, Gus Grissom, Ed White, and Roger Chaffee, were performing a simulation plugs-out test. The plugs-out test was to test the internal batteries of the vehicle. Since no fuel was being used in the procedure, it was not marked as a hazardous test. Although the testing had undergone a few reschedulings during the week leading up to it, it was going according to plan. The tests were running smoothly as they worked on a communications issue. All of a sudden, at 11:31 p.m. GMT, a distorted voice from Grissom said, "We've got a fire in the cockpit," as the fire began at the left wall of the capsule. The final transmission was made by Chaffee when he said, "We're burning up." The fire spread rapidly throughout the cockpit with the aid of nylon for fuel and a high concentration of oxygen. At this point, technicians reported seeing an orange glow in the window of the capsule. As the fire quickly grew inside the cockpit, so did the pressure. The pressure soon reached the maximum capacity the module could hold, and its hull ruptured, releasing flames. Technicians immediately began searching for the tool to open the hatch door. However, the smoke that had built in the area made this difficult. The technicians soon began efforts on removing the hatches. However, the presence of the liquid fuel nearby caused them to hesitate. After a long 5 minutes, the technicians were finally able to open the door. After some difficulty searching for the crew, the technicians were able to find them where they immediately stated that they were dead. Although people working around the spacecraft wanted to get the astronauts out, there was no point. Furthermore, doing so would not have been advantageous due to the fact that photographers needed to take photos and that the astronauts' suits had been fused to the nylon in the capsule during the fire. The bodies of the crew members were eventually removed from the cabin approximately 7.5 hours after the fire took place. The module was disassembled over the next 2 months in order to try to find the cause of the fire.
The cause of the Apollo 1 fire has been debated amongst investigators throughout the 50 years following the accident. It is difficult to hold one failure accountable for the fire, as it was more of the culmination of multiple accidents occurring at the most inconvenient time. As this disaster occurred in the early days of space exploration, Apollo scientists didn't take the necessary precautions to prevent catastrophes. The Apollo 1 fire can be primarily linked to an overabundance of oxygen, a highly flammable gas, in the command module. This, along with a suspected instance of faulty wiring and the abundance of aluminum used to construct the spacecraft, is what may have led to the death of the 3 test pilots on board. After a fire had sparked inside the cabin, the spark carried enough heat to ignite the oxygen in the interior of the spacecraft. This fire is reported to have burned very quickly, generating a large amount of heat. This heat caused cooling systems containing glycol and water to melt and ignite the mixture, continually feeding the fire with oxygen, allowing it to remain lit. As the spacecraft consisted of an abundance of aluminum, a metal that melts at temperatures exceeding 660 degrees Celsius, the module had a chance of contorting to prevent the astronauts from escaping. After these events occurred, movements were made to convert the environment inside the craft from a pure gas environment to a mixed gas environment. However, NASA scientists were short on 2 things, power and time. To change the environment inside the spacecraft would have added more weight to the spacecraft, a luxury they could not afford, especially when taking into account the lack of time on their schedules to get man to the moon. With only around 2 years separating the incident of Apollo 1 to having Neil Armstrong set foot on the moon, the amount of work and tests that NASA conducted is staggering, launching a test vehicle roughly every 2.5 months. More meticulous detail and precision has been implemented into the construction of spacecraft since the Apollo 1 fire, being a direct result of the incident. NASA has learned an unbelievably large amount over the course of the last 50 years, allowing man to reach the moon and put rovers on Mars. However, without these brave astronauts risking their lives, the history of space exploration may have been much more gruesome of a path.
Due to the severity of the accident, the entire Apollo program came to a halt, and all research and development was suspended. All of the efforts at NASA were directed into an investigation of the deadly fire. The purpose of this investigation was to discover the causes of the lethal fire and to identify what changes to the spacecraft must be made to prevent such a disaster from ever happening again. At the end of the investigation, NASA made numerous changes to the vehicle itself, including fundamental design changes, a redesign of the entire life support system, a new hatch, and even the addition of new flame-retardant materials for use in the spacecraft. Immediately after the accident, crews of engineers reviewed the charged spacecraft in search of the cause of the disaster. They identified the most disturbing cause of the fire, the 100% pure oxygen atmosphere inside the spacecraft. When exposed to such a high concentration of oxygen, everything is flammable. The spark could easily ignite it and quickly spread to the entire spacecraft. The most critical correction that was made to the Apollo spacecraft was the redesign of the life support system. All of the Apollo spacecraft going forward had used a 35% oxygen environment, which is much closer to the oxygen concentration of the air. This change alone would likely have been sufficient to eliminate the threat of such a disaster happening again. But the engineers at NASA had many more changes to make. The second change that was made to the Apollo spacecraft was the redesign of the hatch. Clara Moskowitz, the assistant managing editor from Space.com, described the unfortunate role of the hatch. Writing, "The investigation later revealed that the hatch opening procedures were way too difficult and took way too long to be executed in an emergency. Furthermore, the inward opening hatch was impossible to open under any pressures higher than normal atmospheric pressure, and the fire had boosted the cabin pressure significantly. The inward opening hatch that prevented the crew's escape was replaced by an outward opening hatch. The advantages of an outward opening hatch are many, but being able to be opened when the pressure inside the capsule is greater than the pressure of the external environment. And they can be opened much quicker. The outward opening hatch that replaced the previous inward opening hatch could be opened in seconds rather than minutes. This design element has had enormous influence and has carried over to every manned spacecraft since. Another design flaw that the investigation revealed was the enormous quantity of flammable materials that were used in the Apollo spacecraft. The investigation noted the prevalence of flammable materials such as Velcro in the vehicle. The fire led to the development of several new flame-retardant materials designed with safety in mind. For instance, the insulation around the wires was replaced with a material so fire-resistant it cannot burn, even in a pure oxygen environment. All of the changes that NASA implemented into the design of the Apollo spacecraft going forward were added with the crew safety in mind. crew safety and disaster prevention became much more important to NASA and the Apollo program after Apollo 1. Apollo 1 has had a lasting effect on engineers working in aerospace and spaceflight fields. Because of the unfortunate circumstances of Apollo 1, all spacecraft since have been much more conscious of the risks and dangers of spaceflight. NASA and other aerospace companies design their vehicles to carry as little risk as possible to ensure the safety of the vehicle's payloads and the crews of those vehicles.